triangle has a unique shape. Any one triangle given three pieces of information forms a unique shape. Having said that, there are two exceptions. Let's think about a triangle. There are 6 pieces of information available. The angles, A, B, C, and the sides, little a, little b, and little c. Now notice that I've labelled the side little b that is opposite the angle B. The side that is little a is the one that's opposite the angle A. And the same, the angle C, little c is the side that's opposite the angle C. Now, if I take 3 of these 6 pieces of information, with 2 exceptions, I will get a unique triangle. Let's just get rid of the exceptions. The first exception is the 3 angles. If I have a triangle with 3 given angles, let's say that one, then I can draw another triangle that is the same shape, only bigger. So I haven't fixed on a unique triangle. There is another way in which that can happen, where we can get more than one triangle. Suppose we are given that side and an angle here. If we've got an angle here, then the side could go on and on and on like that. Say I was given the length of this side, and say I was given a length that was that long. Well, there's also another triangle up here that has the same length, there and there. And so what I've got there are 2 triangles. I've got a big one and I've got a little one. And I've got those out of 3 pieces of information: the length of that side, the length of this one, and that angle. But those are the only 2 cases where if I take any 3 of these pieces of information, I will get a unique triangle. These are the 2 exceptions. Okay. Because that means a triangle is fixed, once I've got these 3 pieces of information, it means that if you're given 3 pieces of information, you ought to be able to calculate the rest. And what we're going to be looking at is formulae that enable us to do that. So, we will begin with a set of formulae that are known as the cosine formulae. First one is cos A is equal to b squared plus c squared minus a squared all over 2bc. So what we've got here at the right-hand side as givens are the 3 sides of the triangle. So we use these formulae when we've got 3 sides of a triangle given to us, and they enable us to work out the angles. I use that in the plural there, but I've only written down one formula. Let's write down the others. Cos B is equal to c squared plus a squared minus b squared all over 2ca. And notice that I've cycled the letters through the formula. Cos of A has minus a squared over 2bc. Cos of B has minus b squared over 2ca. And so we ought to be able to predict what the cos of C is going to be. And that will be a squared plus b squared minus c squared all over 2ab. So whilst they look complicated, they're very easy to remember. So we use when given 3 sides to find angles. Now we can actually rearrange these. So let's take this first one, do a little bit of algebra, and see how we can make use of the result to generate some more equations. So b squared plus c squared minus a squared all over 2bc. First of all, we can multiply up by the 2bc. So we have 2bc cos a is equal to b squared plus c squared minus a squared. And now I can add an a squared to each side and take this lump away from both sides. And that will give me a squared is equal to b squared plus c squared minus 2bc cos a. And that is a formula for getting the side A. What do the other ones look like? Well, b squared is going to be equal to c squared plus a squared minus 2ca cos b. And notice we've cycled the letters through the formula again. And c squared is going to be equal to a squared plus b squared minus 2ab cos c. So the cosine formulae are actually made up of 6 formulae. 1 for each of the angles, that's 3 altogether, and another one for each of the sides, and again that's another 3. When would we use these formulae? What are we being given on this side? Well, obviously we're being given 2 of the sides, A and B in this case, and an angle. Let's just repeat the diagram again, where we've got the angle A, the angle B, and the angle C, and the labelling, little a, little b, and little c. And let's have a look at this formula here. We're finding c when we've been given A, when we've been given B, and when we've been given the angle C. So we're using these formulae to find a side, C, when we are given 2 sides, and the angle between, or the angle included between the 2 sides. So, those are the 6 cosine formulae. You only need to learn 2 of them. 1 for the angle, 1 for the side, and then just cycle the letters through to find the others. Another formula is the sine formula. And the sine formula looks like this. A over sine A is equal to B over sine B is equal to C over sine C is equal to 2R. What on earth is R? Where did that suddenly come from? Well, that's just to complete the formula. And what R is equal to, R is the radius of the circumcircle. So the circumcircle is the circle that we can draw that will go through all the points of the triangle. And that's R. So where R is the radius of the circumcircle. and that's the circle that goes through all the points of the triangle. Because we can write A over sine A is B over sine B is C over sine C is 2r, if we just leave off the 2r, we can turn that upside down and write it as sine A over A equals sine B over B equals sine C over C. And we can use it that way up as well. And when do we use this? Well, if we just look at that bit, if we need to find one of these four things, the side A, the angle A, the side B, or the angle B, just need to find one of those four things, we've got to know the three others. So we have to know two angles and a side, and it is the non-included side. If we look at this one, and we want to find one of these four things, say we want to find the angle A, we have to know the two sides and the angle B, and it will be the non-included angle. So, we can use this either to find a side, given two angles and a side. Notice if we're given two angles, we actually know all the angles, because the angles of a triangle add up to 180. Or we can use it given two sides and an angle to find a second angle. Now, let's have a look at some examples. So we'll take an example where we begin with A is 5, B is 7, and C is 10. So we are given all three sides of the triangle. And having been given all three sides of the triangle, what we've got to do to solve the triangle is find the three angles. So that's going to be our cosine formulae. So we'll start with cos A, which is going to be B squared plus C squared minus A squared all over 2BC. So we can put our numbers into there. B squared, that's 7 squared, plus 10 squared, minus 5 squared, all over 2 times 7 times 10. 7 sevens are 49, 10 squared is 100, and 5 squared is 25, all over 140. 2 sevens are 14 and times by 10. Bit of arithmetic, we've 100, add on 49, take away 25, that's 124 over 140. And what we need to do is to work this out and find out what the angle is. The angle A is the angle whose cosine is 124 over 140. And for that, we need to use a calculator. So, let's set up our calculator. Turn it on. Choose the right mode. I'm in radians. Normally, in doing these calculations, we would want to have our calculator in degrees. So we'll just switch that into degrees. And now we can work this out. We want the angle whose cosine is 124 divided by 140, and that is 27.7 degrees, working to one decimal place. Well, that's one angle of the triangle. I can go ahead and use the formula again and find the second angle of the triangle, and then I can use that information to find the third one by adding the two that I know together and taking them away from 180 degrees. So now let's take another example where we need to use a different set of formulae. We'll take B equals 10, C equals 5, and the angle A equals 140 120 degrees. Let's sketch this first of all so we can see exactly what information we've got. So here's the angle A, 120 degrees. B and C, two angles that we don't know. And here, this is the side little b, which is equal to 10, and the side little c, which is equal to 5. And this is the side that we want to be able to find, little a. Well, we've got two sides and the angle between them. So that suggests to us that we want to use a squared equals b squared plus c squared minus 2bc cos a. Because this is what we're given. We know b, we know c, b and c, and we know a. And this will help us to find a. So, let's put the numbers in. B squared, b is 10, so that's 10 squared. C squared, c is 5, so that's 5 squared, minus 2 times b, which is 10, times c, which is 5, times the cosine of 120 degrees. So, this is 100 plus 25, 5 squared, minus 2 times 10 is 20, times 5 is 100, times, and the cosine of 120 is minus 0.5. So this is 100 plus 25, that's 125. 100 times by minus a half is minus 50, but we've got this minus sign here. So that's minus 50 is plus 50 altogether, gives us 175. It's a that we're after, so we need to take the square root of 175, and the square root of that is 13.23, and we'll give the answer to 2 places of decimals. So now let's take a third example. And in this case, we'll have C is 8, B is 12, and the angle C is 30 degrees. Okay, first we need a sketch. What information have we been given? So label our triangle A, B, C. Label the sides, little a, little b, little c, and put the information on. So C is 30, B 12, and the side little c is 8. So we've got two sides and an angle. We don't have the angle included between the two sides. So this is the sine formula. So remember, that's A over sine A is B over sine B is C over sine C. Or we can use it the other way up. Sine A over A is sine B over B is sine C over C. Now, which bits do we want? Well, we've got B is 12, so we've got that one. We've got little c is 8, that's that one. And we've got the angle C is 30, that's that one. So it looks as though it's this box that we're going to be using, and the angle we're going to be finding is B. So let's work with these, because the sine B is on the top. So let's write that down separately. Sine B over B is equal to sine C over C. And let's put some numbers in. This is sine B over 12 is equal to sine of 30 degrees over 8. And so sine B is 12 times sine 30 degrees over 8. Now that's fairly complicated, and I could use a calculator straight away. But one of the things that I do recognise here is that sine 30 is a half. So I've got 12 times by a half and divided by 8. 12 times by a half is 6, still to be divided by 8, which gives me 3/4, or 0.75. So my angle that I want, B, is the angle whose sine is 0.75. So, let's bring up the calculator again. We want the angle whose sine is 0.75, and we see that the angle that we get is 48.6 degrees, working to 1 decimal place. Now, there is a potential complication here. Let's go ahead and just have a look at the possibilities in this particular question. And it's to do with these angles. Because B needn't just be 48.6 degrees. Remember that C is 30 degrees, and that's fixed. B is 48.6 degrees, or 180 minus 48.6 degrees. Could be either. Both have a sine of 0.75. So B might be that, or, taking this away from 180, 131.4 degrees. Now the question is, what's the other angle? Is it possible to have an angle A with these sets of figures? Well, in the first case, we can have C is 30 degrees, B is 48.6 degrees, and the angle A will be 180 minus the sum of these two. In other words, minus 78.6. And so that will be 101.4 degrees. So yes, we can have that particular combination. What about the other combination? C is 30 degrees. B this time would be 131.4 degrees. And so A would be equal to 180 minus the sum of these two, 161.4. So this gives us an angle of 18.6 degrees. It's still possible. And this is the case that we came across before, where we've got one side, where we've got an angle, and where it's possible for the other side to meet twice. Once there and once there, and still produce a triangle that works. What this means is that we know this side, we know that one and that one, because they're the same, so we would have two sides to find. One for the smaller angle A and one for the larger angle A. A difficult one, but we do have two distinct triangles from the same set of information. Okay, we've dealt with the sine formulae, we've dealt with the cosine formulae. What we want to have a look at now is just the set of formulae which will give us the area of a triangle. So let's just draw a triangle. Most people are happy with the idea that the area of a triangle is a half times by the base times by the height. What does that mean in this triangle? Well, it's this way up, so to speak. This is the bottom of the triangle. So this is, let's say, the base. What's the height? The height is the distance of the highest point from the base. And in this case, we mean the perpendicular distance, so that that line meets the base at right angles. And then this is the height. What if we are given information about this triangle? So let's label it in the same way as we did before. Now, this means the base in my picture is the side little a. That will be the side little b, and that will be the side little c. Let's look at this right-angled triangle. Here, the hypotenuse is c. The thing that I've labelled the height is the side that is opposite to the angle b. Let's assume that I know the angle b and I know the side little c. Then in this right-angled triangle, the height divided by the hypotenuse, c, is equal to, well, remember, height is the opposite side, and so that is going to be sine b. And so what I have there is that the height of this triangle is c sine b. The base is little a, so I have the area is a half AC sine b. Now it's reasonable to ask, since this formula involves three pieces of information, two sides and the angle, can I cycle through again? Can I cycle these letters through? Well, let's have a look over at this side. And again, we see that the height is the opposite to angle C, and that B forms the hypotenuse. And so I can have the area is 1/2 times the base A times B sine C, because that's what the height is in this right-angled triangle. Well, it's not too difficult to see that the remaining one is going to be 1/2 BC sine A. And so we have three formulae that give us the area of a triangle. Again, we need only learn one of them, because we can get the other simply by cycling through the various letters. So, the area of that particular triangle A, B, C, the angles A, B and C. The area formulae that we had were 1/2 AB sine C and 1/2 BC sine A and 1/2 CA sine B. Let's check what information we've got here. AB sine C, AB the angle C. So again, it's two sides and the angle between. Two sides and the included angle. We don't always get that sort of information, though. One of the things that we do know is we can be given all three sides of a triangle. What then? Well, an ancient Greek, wouldn't you know, by the name of Hero, according to some texts, or Heron, according to others, had a formula for calculating the area of a triangle when you know all three sides. And his formula goes like this. The area is the square root of, and you can tell it's going to be a big expression because I put a big bar on that square root sign, S times S minus A times S minus B times S minus C. What's S? A, B and C are the lengths of the sides, but what's S? Where S is equal to A plus B plus C, all over 2, the semi-perimeter. Semi-perimeter, because A plus B plus C is the perimeter, it's the distance all the way round, we divide it by 2, it's the semi-perimeter. So this is Hero's or Heron's formula for finding the area of a triangle. So let's have a look at an example of each. So in the first case, we'll take A is 5, B is 7, and C is 10. And we're trying to find the area of a triangle. And what we've been given is the lengths of the three sides, little a, little b, and little c. So that means we're going to have to use Heron's formula. The area is the square root of S times S minus A times S minus B times S minus C, where S equals A plus B plus C all over 2. And that's got to be our first calculation. So we're 5 plus 7 plus 10 all over 2. 5 and 7 is 12 and 10 is 22. Divided by 2 gives us 11. So now the area is equal to the square root of 11 times 11 minus 5 times 11 minus 7 times 11 minus 10, which is the square root of 11 times 6 times 4 times 1. Square root of 6 times by 4 times by 1 is 24, and what we need is 24 times by 11. 11 fours are 44, 2 11s are 22, and the 4 gives us 26. So the area is going to be the square root of 264. And again, we just need the calculator to be able to work that out. Turn it on, get into the right mode, and we want the square root of 264, and that is 16.223 significant figures. So the area is 16.2 square units. I didn't say what the units were here for the lengths of the sides, so these are just units, square units for the area. So now let's have a look at an example using another set of data. So in this case, we'll take B to be 10 and C to be 5 and the angle A to be 120 degrees. And we want the area of the triangle. So a quick sketch, let's just make sure we know what we've got. A, B, C, this is 120. B we know to be 10, and little c we know to be 5. So we've been given two sides and the angle between, the included angle. And so straight away we know we're all right to use the area is a half BC sine A. Put the numbers into the formula, a half times 10 times 5 times sine of 120 degrees. So 10 times by 5 is 50, and a half is 25 times by the sine of 120 degrees. And so we need the calculator again to help us work this out. So bring the calculator up and turn it on and get into the right mode. And now we need 25 times the sine of 120 degrees. And that gives us an area of 21.7 working to three significant figures. And again, this will be 21.7 square units. I didn't specify what units these were in. Had they been centimetres, then this would be 21.7 square centimetres. So now, let's just sum up what we've got. We've got our set of cosine formulae. One representative is cos A is b squared plus c squared minus a squared all over 2bc. And there are another two like that for the angle B and for the angle C. And we know how to generate them by cycling the letters through. We also know that a squared is equal to b squared plus c squared minus 2bc cos A. And we know that there are another two like this. We know how to get them. We simply cycle the letters through the formulae. This one, we find angles using three sides. This one, we find a side using two sides and the included angle. We next have our sine formula. A over sine A is equal to B over sine B is equal to C over sine C is equal to 2r. And remember, that r was the radius of the circumcircle, the circle that went through all 3 points of our triangle. And we can turn this the other way up, and we can say sine A over A is sine B over B is sine C over C. And we use this when we're given two sides plus an angle, but it must be the non-included angle, or when we're given two angles and a side. So, those are our cosine formulae, those are our sine formulae. The area formulae we've just had, remember Heron's formula, and the other formula for the area, a half AB sine C, that's just one representative, and the others we cycle the letters through. And finally, let's see if we can connect two of these sets of formulae that we've just had. Just draw a triangle so that we can recall the notation. The capital letters for the angles and little letters on the sides opposite to the angles for the lengths of the sides. Now, the area formulae told us that the area was equal to a half AB sine C, a half BC sine A, and a half CA sine B. Well, let's take two of these and actually put them equal to each other. After all, they're both expressions for the area of this triangle, and so they are in fact equal. So let's write them down. A half AB sine of C is equal to a half BC sine of A. Well, immediately we see we've got a common factor on each side of a half and a common factor on each side of B. So we can cancel those out on each side. And that will leave us on this side here with A sine C, and on this side it leaves us with C sine A. Now, if I divide both sides by sine A and divide both sides by sine C, then I have A over sine A is equal to C over sine C. So working with the formula for the area, we have derived a part of the sine formulae. If I take another two of these, say these two together, I'll get another bit of the sine formula. So we see that these two are related, the area formulae and the sine formulae, and we can derive the sine formulae from the area formulae very simply.